find the horizontal asymptote, simply compare the degrees of numerator and denominator. Remember, in our definition, rational function is in the form of p of x over q of x. And then our p and q are polynomials. So if we're going to write that one in standard form, our polynomial is in descending order when it comes to the exponent. So it follows that our first term here in the numerator, it is the term with the highest degree of exponent. So in the numerator, our degree of exponent is equal to m, and then below we have the degree of exponent equal to n. Now we have three conditions to check if the given rational function has a horizontal asymptote. So the first one is if m is greater than n, then there are no horizontal asymptote. Ano ibig sabihin yan? Pag yung exponent daw ng nasa numerator ay mas malaki kaysa sa denominator, ibig sabihin wala tayong horizontal asymptote. We are talking of degree of exponent, yung may pinakamataas na exponent. Another condition, if m is less than n, then y is equal to 0 is our horizontal asymptote. Next, if m is equal to n, then our horizontal asymptote is equal to a over b, wherein our a is the leading coefficient in the numerator with the highest degree of exponent, and then b is the leading coefficient in the denominator with the highest exponent. Okay, so let's have example. So g of x is equal to 3x plus 6 over x minus 2. So to check if we have horizontal asymptote, we have three conditions. The first one is if m is greater than n, then we have no HA or horizontal asymptote. Next, number 2, if m is less than n, then our horizontal asymptote is at y is equal to 0. Next, number 3, if m is equal to n, then our horizontal asymptote is equal to a over b. So we divide the leading coefficient of the numerator and the leading coefficient in the denominator with the highest degree of exponent. Now, we have here g of x is equal to 3x plus 6 over x minus 2. So, if we're going to compare the exponent, they have the same degree of exponent. So, we have 1 and then 1. So, we apply the condition m is equal to n, wherein we divide the leading coefficient. So we have now y is equal to a over b. So we have y is equal to, so the leading coefficient in the numerator, we have 3 and then we have 1. So it is understood that we have here the coefficient 1. So simplify, we have now y is equal to 3. So our horizontal asymptote is at y is equal to 3. Now let's have another example. So another example, we have f of x is equal to 2x raised to 2 plus x minus 1, and then below we have x plus 3. So again, In finding the horizontal asymptote, we simply compare the exponent. And we have to make sure that the arrangement of our polynomials is in standard form. So, descending order. May pinakamalaking exponent, that is our first term. Okay? Now, as we can see, the arrangement is descending order, same also below. Then, we compare the exponent. So, as you can see, the degree of exponent in the numerator is greater than the degree of our denominator. Then, our horizontal asymptote is at y is equal to 0. Okay, so let's have another example. F of x is equal to 3x squared plus 2x, and then over 4x raised to 3 minus 5 plus 7. Okay, so again, we have to set the polynomials into standard form. So it is in standard form. Then the next thing we're going to do is we compare the exponent. So as you can see, our exponent in the denominator is greater than the exponent in the denominator. So our horizontal asymptote is equal to a over b. Our leading coefficient in the numerator is 3, and then our leading coefficient in the denominator is 4. So we have now y is equal to 3 over 4 as our horizontal asymptote. Now if we're going to graph, so this is our y, this is our x. So our horizontal asymptote 2 is along x-axis, or y is equal to 0. So if we're going to illustrate the horizontal asymptote in number 3, so y is equal to 3 over 4. So this is 1, this is 2. So our horizontal asymptote is at 0.75, positive 0.75 approximately. So we have now our horizontal asymptote. So in problem number 2, our horizontal asymptote is along the x-axis, or y is equal to 0. And then in problem number 2, our horizontal asymptote is at 3 over 4, positive 3 over 4. So again, to find the horizontal asymptote, we need to check the three conditions. The first one, if m is greater than n, then we have no horizontal asymptote. And then for number 2, if m is less than n, then our horizontal asymptote is at y is equal to 0. And then last one, if m is equal to n, then we divide the leading coefficient in the numerator over the leading coefficient in the denominator. So that is the process in finding the horizontal asymptote in a given rational function.